Hello everyone. So today we are going to discuss another problem on LL1 parsers. This is a topic from basically compiler design, right? LL1 parser. You must have heard of it. So the following productions of P of grammar G, L, Q, R, A, B, C, L and P is not suitable for a top-down predictive parser. Top-down predictive parser means for a given substring it will just basically use all the productions and try to find out the terminal which the non-terminal basically points to. So this is a top-down parser, and in case of bottom-up the reverse happens. Using reductions we change back to basically the non-terminals. So this is how it works. So let's see. We are given identify the problems and correct it by rewriting the grammar. So the grammar is this, if that image is not visible clearly. So this is the grammar, and if we try to see that first problem in this will be left factoring. Left factoring means like if A is a non-terminal and A points to A comma B, AB and basically C, suppose. So then we will see that A points to A and B. Then if again A points to A and B and this continues up till infinity. So this is a problem for this parser. This particular parser cannot handle a grammar with the left factoring. So we need to remove that. So for this, as I have taken an example as well here. So this is a basically example of left factoring. So what we can do is we have to use this formula. So in this formula, A and beta are, A is non-terminal, alpha and beta are terminals. So A will basically point to beta A dash. We have introduced a new non-terminal A dash, and A dash in turn points to alpha A dash or epsilon. Epsilon means no string, that is which we can in programming languages we have the double quotations. So this is what epsilon means. So we'll just apply this particular formula here. So if we see above, only this part has the left factoring, right? So what we can do is for these two, these are non-terminals, so we can put it in first and then introduce R dash, right? And after that R dash will correspond to this BC, this one, and BC R dash or epsilon, just as we did here. So this was one of the problems. Now the second problem here is basically left factoring. I have written twice. It is left recursion. Okay, it is left recursion, not left factoring. The next problem which we are going to discuss is left factoring. So in this, what we can see that in the above problem, if we check, Q points to BBC or BC, but since this is a top-down parser, so we are assuming that only one element of the basically memory is visible at a time to the compiler. So it is only able to view this B. It does not know whether it has to use this rule or this rule, right? Both can occur, means this B can be this B also or this B also. So we need to basically eliminate this confusion out of the grammar, otherwise it will be ambiguous. So for doing so, what we will do is, suppose we are given here BB dash, BBC and BC, right? So B points to Q dash, we have introduced a non-terminal again, BC or C, right? And Q dash will point to B comma epsilon. We can check that if first Q is basically checked, right? If Q is there or not. So it will check if there is a B or epsilon. If there is like no string in their case, then it can be BC or B and then BC. So you can check all of the strings which are basically approved by this grammar can be handled by these two rules. One of the thing which students do wrong is they will take q to bx, which is again a non-terminal, and means bx or x, and x will point to bc. But the problem here they forget to basically take into consideration is b is still encountered on the first in both cases, right? So the grammar will still remain confused as to which rule it has to take, because b is appearing twice. So once it basically sees b, so it will not be able to guide itself that which one to take. So the corrected grammar will be the following below. All we have done is just combine these two and these two, so then we have the corrected grammar. So this was the corrected grammar. Then we have to show that the new grammar satisfies the LL1 condition. So LL1 condition means that basically we have to create the LL1 grammar, which is this, and it should, when we form the parse table, there should be no conflicts in that. If we are able to make a parse table without any conflicts, then we will say that the grammar is LL1 parsable. So for making the grammar, we will first consider creating the first of all the non-terminals. So for all the basically productions, we will see L to RA comma QBA. So if we check, and one more thing, when you are trying to find out the first of any grammar, try to go from bottom to top. It will basically help you in assigning firsts to the non-terminals. So if we check Q dash, it will have B and epsilon, right? And then if we check Q, so Q points to Q dash, and the first of Q dash is B, so it will have B, or it can have C, so again C. Next R dash, it will have B and epsilon, right? Then R, it will have A and C, right? Then for L, it will have R. The first of R is basically A comma C, so we have A comma C. Then first of Q, so first of Q is B comma epsilon, so B comma epsilon. Just we need to check the first terminal which is appearing in the production. If there is no terminal, then the non-terminals first, and similarly other non-terminals. Now let me show you how to create this table. So we will have L and L as the basically non-terminal and A as the terminal, and we will check when A comes as the first of L in which production. So if we see above, in the production RA, it comes as first, since R has the first A, so we will write this this production. Then again for Q, we will see that Q goes to Q dash and Q dash goes to B, so L has QBA in the B part. And again for R, A in C part, since R will go to C as the first, and again L to Q PA, since first of L in this production will be epsilon. Then again for R, we will have R to A in the column of A, because A comes as the first of R, and here C A B A R dash in the column of C. Next in R dash, we will have R dash to BC R dash in B, and R to epsilon in epsilon column. Similarly, we will calculate the others like Q to Q dash BC for B, and for C we will have just C only in this production. Then Q dash has B and epsilon. So this is the table. Since there are no conflicts, so it is an LL1 grammar right now. Okay.